All right, so if you haven't watched a couple questions ago, you should do that first. It says rank the following in terms of decreasing viscosity. And it says you may have already drawn the Lewis structures. So in question one, these are the letters. So we have these Lewis structures from question one, and we have their strongest intermolecular forces, which are now shown here. And a couple questions ago, we talked about how viscosity is directly proportional to intermolecular forces. So the stronger the intermolecular forces, the stronger the viscosity, or the higher the viscosity. So in this case, we want decreasing viscosity, so we want the highest first. And it's always a good idea to ask yourself, should the highest go first or should the lowest go first, so you don't write it backwards accidentally. So the one with the strongest intermolecular forces is going to have the highest viscosity. And in this case, PBr3 is going to have dipole-dipole forces, so therefore it's going to have the highest viscosity. Now, if we look at CBr4 versus CS2, they both have dispersion forces. So in that case, we're going to want to go by molar mass. So CBr4 has a molar mass of 331.63 grams per mole. CS2 has a molar mass of 76.14 grams per mole. Now, I will note the molar mass doesn't always work, but when they're this different, okay, it's going to work. So in this case, the one with the higher viscosity is the larger molecule. You can think about it as the electrons are more spread out, therefore they're more polarizable when they're bouncing around and bouncing into things. So this is going to be decreasing viscosity. So PBr3 is greater than CBr4, which is greater than CS2, which in this case, they happen to be in the right order, but that's just a coincidence. So this is how you would do it. Note that to compare between dispersion in one molecule and dispersion in another, you are going to use molar mass here. Sometimes you would use shape if they had the same molar mass, for example.